Good morning, Honors Chem. We're going to talk about mole conversions one more time, and this time we're going to do some two-step mole conversions. So let's remind ourselves right now, what we've learned so far is how to change particles to moles, moles to mass, moles to volume, so on and so forth. So here's our 4 things that we have dealt with, which is particles, moles, mass, and volume. Now notice when you're going from moles to mass, it says when you're going from moles to mass, you multiply. When you're going from mass to moles, you divide. You divide by the molar mass. And when we find molar mass, when we talk about molar mass, we're talking about the periodic table of the elements. Now, if you're just talking about an element on the periodic table of the elements, it's simply the number there. So if I were to look on my periodic table of the elements, and let's find, say, sodium. 1 mole of sodium has 22.99 grams. But what if I don't have an element? What if I have a compound? So if you want step-by-step instructions, again, you can go back to the introduction to the mole video. We did a couple of them in there. For example, we did 1 mole of O2 is not 16 on the periodic table of the elements because of this. It is 2 times 16. So 1 mole of O2 has a mass of 32.00 grams. Now let's talk a little bit about something more complicated. How about a compound that has 2 different elements? Well, in this case, you have 1 carbon. So I'm going to look up 12.01 for carbon. And then I'm going to have 2 oxygens in grams. So in my calculator, I do 12.01 plus 2 times 16, and I get an answer of 44.01 grams. This is the molar mass of carbon dioxide, adding up the digits or the numbers on the periodic table of the elements. Let's do something a little bit more complicated. How about 1 mole of calcium nitrate? Now let's clarify. This is actually calcium. 1 calcium has 2 nitrates, like such. So this 2 belongs to, you distribute it out to the nitrogen and the oxygen. So I have 1 calcium at 40.08. I have 2 nitrogens at 14.01. And I have 6 oxygens, not 5, 6 oxygens at 16. Add those all up and I will get an answer, and I'm going to round my answer to 4 digits. At 164.1 grams. Your calculator is going to tell you 164.10 grams, which is just a difference of significant figures. So that's how we get the molar mass from the periodic table of the elements. Every single element and compound is going to have a different molar mass. The particles and volumes are easier because for particles, you're always dealing with 6.02 times 10 to the 23rd. Again, if you're going from moles to particles, you multiply. If you're going from particles to moles, you divide. When we're going from moles to volume, you multiply by 22.4. If you're going from volume to moles, you divide by 22.4. Okay, let's do some problems together. We're going to do some two-step problems. You have a whole video on one-step problems if you need to go back and review. Here's the mole card from your periodic table of the elements. We're only using these boxes so far. If you want to use the other mole card that I was just using, that's fine. I'm just trying to get you comfortable with this one because we're going to need all these boxes at some point in time. So let's say a problem asks us, if I have 97.8 liters of carbon dioxide, how many grams of carbon dioxide is that? So my given is the one that comes with the numbers, 97.8. I'm going to be super careful to have my units and labels. Remember, I promised you that would become important later. My first step is to figure out where I'm at on the mole card. So liters is a volume. So this problem, I'm going to start at volume of a gas. And they're asking us to find mass, which is grams. So you notice I am going to start at volume. I have to go through moles first and then mass. There is no conversion factor that takes us straight from volume to gas. Volume of a gas to mass. So we first have to change to moles. So in order for liters to cancel out, I need it to be on the bottom and moles to be on the top. $22.4 goes with liters. You see in the conversion factor, it's written right here in this conversion factor that there's 22.4 liters in 1 mole. So 22.4 always goes with liters and 1 always goes with moles. Now I'm going to go from moles to mass. I need moles to cancel out now, so I'm going to put it down here. Remember, I added up carbon dioxide, which is 1 carbon and 2 oxygens, to get the grams of carbon dioxide. I did that up top, and it was 44.01 grams in 1 mole. So in your calculator, you'll type in 97.8 times 1 times 44.01, enter, and then you divide by the bottom, which is 22.4. I'm going to answer to 3 digits, so I'm going to get an answer of 192 grams of CO2. Okay, let's do, keep rolling on. Let's do a different problem. If they gave us 115.4 grams of calcium nitrate, and they asked us to find how many formula units. Remember that atoms is a single piece of an element. Molecules is a single piece of a covalent compound, and a formula unit is a single piece of an ionic compound. So I'm going to take my given with units and labels. Put it over 1. This time, I'm starting in grams up here, which is a mass. And I'm asked to find formula units, which is in this particles box. Remember, particles, atoms, ions, formula units, and molecules only labels and units that we can put on that big giant number of 6.02 times 10 to the 23rd. So I'm starting up here at grams. I'm going to start at grams. I got to go to moles first, and then I've got to go to particles. That's 2 arrows, 2 conversion factors. So if you remember up top, we calculated that in 1 mole of calcium nitrate, there's 164.1 grams. First of all, let's deal with our units. Grams needs to go down here to cancel. And I need to go to moles. I can't go straight from grams to formula units. I need a 2-step problem for this. If you look at the conversion factor, you'll see that moles gets the number 1, and grams gets the number off the periodic table of the elements, like such. Now I have to convert moles to formula units. Moles will have to go on the bottom to cancel, and it always gets the number 1. And then formula units, 6.02 times 10 to the 23rd formula units of calcium nitrate. This is the one where you have to be careful that we're going to be using our scientific notation or exponential function on our calculator. So I don't use the times sign and I don't use the number 10. I type in my calculator 6.02. To type that number, you type in 6.02. It's either going to say EE or EXP and then 23. That's how you type that number in. Your screen is going to look like 6.02 E23. So I'm going to multiply across the top. I multiply 6.02 times 10 to the 23rd times 115.4 and divide by 160.10. Now my calculator is going to look like this. It's going to say 4.233. It's going to have a bunch more digits depending on what you tell your calculator how many digits you want. So it's going to be different for everybody. And then it's going to say E23. I have to be super careful. This answer, if I miss the fact that there's an E and I report it as 4.233, that's super wrong. The other thing is, when you're talking about formula units, you can have 1, you can have 2, you can have 3. You can't have 4.233 of them. You can only have a whole number of particles. So I'm going to expand this out. My answer will be reported as 4.233 times 10 to the 23rd formula units of calcium nitrate. Like such. Let's do one more problem together before you guys give it a try yourself. 9.64 times 10 to the 24th molecules of P2O5 would have how many liters of P2O5? Remember, we can only use 22.4 liters when we're talking about a gas. So I'm going to take my given, put it over 1. I'm going to go to my mole card and say I'm starting with molecules, which is this box right here that says particles. Sorry, we're getting a little messy here, aren't we? So we're going to start with particles because I see the word molecules in there. And I'm asked to find liters. So this time I'm going this way. I'm starting at particles and I'm ending at volume. I can't go straight from particles to volume. So first I have to change particles to moles, and then I have to change moles to volume or liters. So molecules First, I change from molecules to moles, and I need molecules to cancel out, so I'm going to put molecules in the bottom and moles in the top. I have to be very careful here because remember, 1 doesn't always go on the bottom. In this case, 1 goes in the top because 1 always goes with the units of moles. And 6.02 times 10 to the 23rd goes with molecules. Now I'm going to change moles of P2O5 to liters of P2O5. 1 goes with moles and 22.4 goes with liters. Multiply across the top. This is one of those ones you have to be super careful with. You're going to type this as 9.64 EE key 24, and then you're going to do times sign, which will look like that on your screen, 22.4. I always press enter after that. And then you're going to hit divided by 6.02 EE23, and then press enter again. Enter, your calculator is going to give you lots and lots and lots of digits, but we're going to round to 3 digits here. So our answer will be rounded to 359 liters. There's just a couple problems, so we will be able to go over some more problems together, and I will post some more examples. But for right now, I'd like you to give some dimensional analysis problems a try yourself. You may work in groups or you may work individually. I am always here to answer questions.